And welcome back, everybody. Here we have with us Nasreddine Bencherchali. Uh, take it away.
All right. Thank you so much. First of all, I wanted to thank the organizers for giving me this opportunity to speak with you today. Today's topic will be common tools and techniques used by threat actors and malware. As stated by Nikos, my name is Nasreddine Bencherchali. A little bit about me. Well, I am a Windows internals enthusiast. I really love threat hunting and detection engineering, as I hope you will see in this talk. I write an InfoSec blog at Medium, where I talk about everything related to malware and threat hunting. On my day job, I am a security engineer at a company called Elite here in Algeria. And you can follow me on Twitter at Nasbench. So the agenda for today will be as follows. I'll first start by talking about the motivation behind this talk. Then I'll dive directly into the tools and techniques in question. And then I'll talk briefly about some detection opportunities, and I'll finish by some resources that I think you should check out for further reading. So, not so many months ago, as I believe everyone is familiar, we were introduced to the SolarWinds hack. It was such a big hack that it shook the community from its base. Well, in this hack, almost everyone got breached. When I say everyone, I really do mean it. We have companies such as FireEye, Microsoft, and Cisco, and even US departments such as the Department of Defense and the Department of Homeland Security. Seeing this, one might assume that this breach is highly sophisticated. And indeed, it was. Reading the many blog posts out there describing this attack, we have seen that the attackers have used some highly sophisticated techniques, such as a unique domain generation algorithm, some highly sophisticated architecture, and of course, they even used some steganography in their web shells. Well, one blog post in particular caught my interest by CrowdStrike, titled "Sunspot and Implant in the Build Process." In their technical analysis paragraph, it reads something like this: Stellar Particle, the guys behind this attack, maintained the persistence of Sunspot by creating a scheduled task set to execute when the host boots. Well, when I was reading this, I really was intrigued by this scheduled task. For everyone not familiar with this, scheduled task is this very little thing that is available in every Windows that comes pre-installed. It lets administrators and users, to schedule their tasks. And seeing such a highly sophisticated attack using such a simple tool made me think and made me question something. What are the tools that are being used by these attackers? For that, I set up on a journey. Well, I researched and read more than 51 reports of the last year from different sources, such as FireEye, Red Canary, the Differ report, and I've looked at some sandboxes analysis from Hybrid Analysis, Triad, and Hatching.io. And this presentation will be the results of my findings. So when we talk about tools and techniques that the attacker use, we can split them into two categories. The first one, we have tools such as Cobalt Strike, Bloodhound, Empire, Mimikatz, PSExec. But on the other hand, we have tools such as searchutil, Reds.exe, PowerShell, RunDLL, etc. And when we make this distinction, we can make it as so. On the left-hand side, we have open source, custom, or commercial tools that the attacker are using. On the other hand, we have Windows utilities or lolbins, living of the land binaries. So before we step into why lolbins, for everyone not familiar with lolbins are everything that comes pre-installed that can be used by attackers in a malicious way. So why lolbins? Why attackers are focusing on this? Well, first of all, they are already there, no download required. So let's say, for example, an attacker gets foothold into your network. He doesn't have to download or install any tools. There are so many tools available out there already. The second thing that is most important is they let you blend in. What do I mean by that? Well, let's say an analyst is looking at its log and is seeing Mimikatz being executing. It for sure will raise awareness. But let's say that it sees run DLL or PowerShell being executed. It is the same utility that their administrator is using, so it will let him blend in. The third thing is the bypass of application control. In most organizations, they think implementing application control by allowing a whitelist of tools can be run on a particular system. So for example, an administrator will only allow PowerShell or some development tool to be run. So if an attacker will bring Mimikatz, it will not be run by default. But since the utilities we're talking about are already there, they can already bypass this whitelist. And the final thing is they offer powerful capabilities. As we're about to see, these powerful capabilities range from dumping LSAS to downloading any executable on the machine, and so many more. Now, before we jump into the tools and techniques in question, let me introduce some key terms and concepts. The first one is the MITRE ATT&CK framework. From their website, the definition reads as so. The MITRE ATT&CK is a globally accessible knowledge base of adversary tactics and techniques based on real-world observations. In practice, what does it really mean? So basically, when we go to the website of MITRE ATT&CK, we are introduced with a table like this, describing a bunch of tactics that the attackers are using. So what are tactics in practice? Tactics are just the ideas or the steps taken by attackers during an attack. So we have, for example, reconnaissance, resource development, initial access, etc. If we take the reconnaissance example and we click on it on the website, we get an ID and when it was created. But what is interesting is we get the techniques related to this tactic. So for each technique, it describes a method that the attacker can use to gain some information on the network. So for example, we have active scanning, and inside that active scanning, attackers can use vulnerability scanning, for example, to get information about the computers and if they are vulnerable to any CVEs or the like. Now, what are the load bins that are being used? We'll go gradually. So the first one is the Who Am I utility. By its definition, it displays user groups and privileges, information for the user who is currently logged on to the local system. So basically, this utility offers the following flag. As you can see here, there are a couple of flags such as /all, /groups, /privs, and they are self-explanatory. For example, the /groups will provide the groups that a particular user belongs to. Well, since this utility is already available, attackers are using it. As we can see in this different report, attackers are using it exactly the same way as a simple administrator. So for example, in this report, we have attackers using whoami/all to gather all the information on a particular user. And from that information, they can move laterally and determine if they need more privileges or if there are something in interest in other groups. Using MITRE, we can map this attack to particular techniques. So for example, the following utility maps to the following techniques: system owner, user discovery, and command and scripting interpreter. Next, we have another tool that is used to test location about domain controller called NL test or network location test. It lists the domain controllers. It can force a remote shutdown, query the status, etc. It has the following flags. For example, NL test /domain trust will give you the trust domain. So once again, let's take a look at how attackers are using this. If you can follow closely here, you'll see that it is the exact same way that an administrator would use this. So it really is difficult to make a distinction between legitimate use and malicious usage. Once again, we can map this to the MITRE attack with the following techniques: domain trust discovery and remote system discovery. Now, we've seen a couple of tools such as Whoami and NL test, and those are very cool, but they provide a static flag. What do I mean by that? They don't offer a dynamic way to modify something. Now, the next tool that we're going to look at is reg.exe. Reg is a Windows utility used to interact with the Windows registry. It can let us query, add, modify, or remove information. So if we see here, we can use the following syntax, reg.save, to, for example, save the HKLM security registry for in a particular path. Now, where it gets tricky is how attackers are using this in the wild. Well, as we can see, attackers use it the same way, but provide a dynamic portion to this command line. For example, we can see here that the reg.exe utility is being used to save the system and the SAM registry hive key to this particular location to later dump the credential from the machine. And we can even see some clever usage and novel techniques in this report by Red Canary, where the attackers are using a very specific location in the registry to add persistence. Once again, MITRE can be used to map these techniques directly. Now, if you remember from the start, we talked about scheduled task, that little utility that enables administrator to create, delete, query, change, or run any scheduled task remotely or locally on any computer. So the syntax goes a little like this. You enter scheduled task, then /create or /change or delete, whatever the action you want to take. Then you specify a time, then a task name, then whatever is going to be run. And you'll get in the interface something like this, the name of the task and whatever the time it triggers at. Seeing how it is being used in the wild, well, the difficulty here lays in the parameters that are being provided. Let's say that you want to search for the malicious usage of scheduled task and make a differentiation between benign usage and malicious usage. You can see clearly here that the arguments are the same, but the path may differ. So you have no other option than to look at, for example, the executables that are being run. In the first example, we have a scheduled task that is being created by the name of K0ADIC that will run the following HTA, which is a malware. Put yourself in the place of an administrator or a malware analyst or a SOC analyst, looking at this in the millions of logs of scheduled tasks that are being executed daily, and you'll soon understand how the attackers behind the SolarWinds breach were able to hide for months using such a simple technique. By simply using scheduled tasks, they can literally hide between millions of lines of logs. MITRE can help us map this technique directly by looking at the scheduled task/job technique. Now, the final LOL-bins we're going to take a look at is the run DLL utility. As its name suggests, it will let us run DLLs. Well, the surprising thing about this is there isn't so many flags. There is only one. You specify run DLL and the DLL name. So, if you look for malicious users with this utility, you'll be surprised that the system uses this utility frequently. And attackers discovered that this can be used to download malicious application directly from the command line. For example, if we look at the first command line utility, we can see that the run DLL utility is being used to execute and download this application. And as you can see, for example, in this line, the run DLL utility is being used to run the end.dll with the function *w. If you put yourself in the place of a SOC analyst looking at this, you cannot determine if this is benign or malicious without knowing what is the end.dll file represents. Now, once again, MITRE can help us map this directly using the following techniques: signed binary proxy execution. So we've only taken a look at a couple of living of the land binaries, but there are so many more. For example, we didn't look at attrib, task kill, icalcals, VSS admin, etc. I highly invite you to take a look at the other tools and how they are being used at my blog, where I detailed everything there. So one might ask a simple question: is there any hope to detect this, seeing that the same utilities that are being used by the system or administrators are being used by attackers themselves? Unfortunately, there are some opportunities to detect this. So the first one is always baseline your environment. And what do I mean by that? Let's take a simple example of PSExec. Well, PSExec is a very well-known utility that its intention was created to be used by administrator to remotely target computers. So when you baseline your environment, basically what are you saying? What is the normal in my environment? And when I know my normal, I can detect what is not normal. So in certain organizations, administrators are using PSExec to administer the computers of their users. But in certain organizations, PSExec is already banned. So when you're writing your detection, you gotta take in consideration this. Is this benign for my usage case, or is it not? If it's not, I gotta create filters and optimize my detection to not take in consideration everything that is generating a false positives. Next, check the command line arguments. So if we take a little example here, we have the SVC host process. On the left-hand side, we have a screenshot from the a sandbox any run of a malware sample executing SVC host. On the right-hand side, we have a screenshot from a Windows machine executing SVC host. So if we take a look, there is a glaring difference. In the Windows machine, the SVC host contains a command line argument. But on the any run execution, the SVC host is without. One other thing to take a look at is SVC host is a child, for services.exe. Whereas in the context of the sandbox, it is a child of spool SV.exe. And that leads me to my next point. Knowledge of OS internals and standard behavior. So in the case of SVC host, when you dig deeper, you will find that SVC host is always a child of services.exe, meaning that anything that deviates from this might be considered and should be considered malicious in some form. SVC host must always have arguments starting with the K flag. So for example, let's say the attacker managed to spawn an SVC host as a service, as a child of services.exe. If it does not contain the K flag, it should raise some alarms. And finally, everything that follows the K flag should be loaded from the HKLM system current control services, or should be defined there at least. And that registry stores information about every service that is declared in the system. And finally, as we have seen, MITRE ATT&CK provide a very good resource to create detection. So as we've seen, it provides tactics such as reconnaissance, execution, etc. And for each tactics, it provides techniques that mapped with that. So for example, we have, in the case of PowerShell, we have the command and scripting interpreter. And when we click on that, we have data sources that can help us where to look to find maliciousness. For example, the data sources to look at to find command and scripting interpreter techniques is PowerShell logs, process command line parameters, process monitoring, Windows event logs, etc. And they even provide a procedure examples of previous attack groups using this same technique. So other resources to look at, the first one is the LOLBAS project. Or living off the land binaries and script. It is a very interesting project that is documenting most of the LOL bins and how they can be used in a malicious way. The second project to look at is the Sigma project, which contains generic rules that can be applied to your CM solutions. And it's already mapping techniques directly from Meta. So you can already go there, search for techniques, and find a specific Sigma rule. And with that Sigma rule, you can convert it to your CM solution and start detecting at a basic level some of the techniques. One shout out I want to make is the DCP podcast by the guys at SpecterOps, which I really find very interesting. Some interesting discussion about threat hunting and detection engineering are there, so you should follow that. And of course, everything related to this and many more, follow my blog at nasbench.medium.com. Thank you so much for your time.
Awesome. That was awesome. We for the moment only had one question trickle in, so we might get a few others coming in, over time. Right. Yes. Could you, let's say, in the context of a big company, do a baseline for your threat detection?
Very interesting question. Technically, well, theoretically, you could, but it takes a lot of time, since even if the company is small, it can take a lot of time. So to my knowledge and to my experience, the best thing to do is go gradually. So for example, enforce things at a smaller scale, for example, at a department or for example, at a couple of peoples, and see what happens from there. So for example, if you want to ban the usage of some utilities, just test it out, base it with your development team or your administrator, see what's happened, and once you're happy with it, generalize it. That's what I think, at least.
Awesome. And we did get a second question. On your personal opinion, which is the best antivirus for enterprise level?
It's a very difficult question. Well, there isn't such a thing as the best antivirus. It is a proactive approach that should be taken to detect maliciousness. So for example, let's say you bought a Windows Defender or something similar. You should always put it and configure it so that it will generate the logs necessary, and then a human is always necessary to take a look at these logs and to determine if something is malicious or not. The human part is always necessary. So the choice of the antivirus will depends on the telemetry that is providing. For example, Defender will provide some telemetry regarding the processes being used and their import tables and something in the like. This could be interesting for your context, so you should go for it. But never replace the human.
Awesome. Well, that's did you have some other things that you wanted to kind of drop in, or like some resources? Are you going to be providing the slides as well, or making them available?
Yeah, I would make these slides available at my GitHub and on my Twitter account. And anyone wanting the slides or wanting to chat about this a little bit more, you can find me at Twitter, and you can ping me whatever you like. I am always available. Thank you so much.